To simplify a rational expression, and a rational expression simply means that you have your variable in the numerator and in the denominator. So since we have the variable in the denominator, this is a rational expression. In order to simplify it, we need to remember that we cannot cancel terms, that we can only cancel factors. Terms are the stuff that's being added or subtracted, and factors are the stuff being multiplied. We do not have factors yet in this expression, as the top is a trinomial and the bottom is a trinomial, or three terms. So no matter how badly the x squared on top and the x squared on the bottom look great to cancel, it's illegal in math land to do that. So instead we factor. We take the top and the bottom separately. So on the top, since this is one of my easy kind of trinomials, I break it into two parentheses and say what times what is x squared. I get x and x. Now I need two numbers that multiply to a negative 8 and add to a negative 2. Well, since my last number is negative, I know my signs are going to be one of each, because that's how we multiply to get a negative. It's a mismatch. So I need two numbers that'll multiply to 8 and add to that negative 2. Well, since it's adding to a negative, my bigger number is going to have to be negative, so I'm going to put the 4 over here and a 2 on this side. We're going to go through the same type of procedure on the bottom, the x squared minus x minus 6. I don't have a greatest common factor, so I go straight into my two sets of parentheses. It's only an x squared, so I know that the only way to do that is an x and an x. Now I need two numbers that multiply to a negative 6 and add to a negative 1. Remember, if there's no number in front of the x, that means that there's a 1 there, because 1 times anything is anything. Once again, because it has to multiply to a negative, I know I need one of each sign, so I may as well put those in right away too. Now the two numbers that multiply to 6 and add to a negative 1 is 3 and 2. Once again, it has to add to a negative, so my bigger number has to be negative, and my smaller number is going to be by the positive. Now that it is in factored form, I am allowed to cancel factors. Factors are the stuff that's being multiplied. So anything that's in parentheses is being multiplied by something else in parentheses, and that allows us to cancel it. So in this case, we have x plus 2 on top and the x plus 2 on the bottom. You cancel the entire quantity or none of it. Anything over itself is 1. Anything times 1 is my anything. So my final answer will be the x minus 4 over x minus 3. Now those factors were in parentheses up here, but they're not down here, mainly because I'm not needing the parentheses to indicate that I'm multiplying those by anything. But if you want to keep the parentheses in there, that's okay to do. Remember, you cannot cancel those x's because those are terms. Now let's try multiplying. The only difference in multiplying rational expressions from our simplifying is that there's more things out there to factor. But it's going to be the same procedure. Factor all of your numerators, factor all of your denominators, cancel common factors that are shared on top and bottom, and then simplify. So we go through every numerator. X plus 4. First thing we always look for in factoring is a greatest common factor. There isn't one between an x and a 4 besides 1, and that doesn't do a whole lot for us. We look then to see, can I break that down further? Well, because my x is just an x and not an x squared, I can't break x down to anything smaller. So I know that the x plus 4 is as far down as I can make it. Now that means that that's whole quantity though, x plus 4 is a factor. So I'm going to write it in parentheses to remind myself that yes, I looked at it, and also that that entire quantity is a factor. So I would cancel all of that or none of it. The x on the bottom, there's nothing I can do with x, so it just comes along for the ride. I'm still multiplying. Now my other top, once again, the first thing we always look for is a greatest common factor. I notice that in these two terms that each of them have an x. So I'm going to pull out that x. Here I had two x's, essentially, that's what x squared means, x times x. I had pulled one of them out, so I'm left with one left. Here I pulled out the x, so I'm left with the minus 3. The binomial I can't break down any further because once again it's x to the first power. Now I do the same idea with the bottom. It's a trinomial. I do not have a greatest common factor in all three terms, so that means I make my two sets of parentheses to unfoil it, essentially. Once again, it's the easy kind of trinomial, as there's only a 1 in front of your x squared, so that means I'm going to start off with x and x. I need two numbers that multiply to a negative 12, so once again I'm going to need a positive and a negative. And it's going to add to a positive 1. Well, that's going to be a positive 4 and a negative 3, as 4 minus 3 is 1. Now that I have all of my parts factored, I get to have the fun part and cancel. Anything on top that matches anything on the bottom cancels out. Now I have an x minus 3 on top here and an x minus 3 on the bottom, so I'm going to cancel those out. I have an x plus 4 on the top and an x plus 4 on the bottom. Those cancel out. Oh look, I have an x on top and an x on the bottom. So what am I left with? Whoa, slow yourself down. Canceling it out doesn't mean that you get 0. We started with something here. Remember, with multiplication, the only way that we get 0 is if one of our numbers was 0. We don't have anything. What do we have left when we cancel stuff out? Anything divided by itself is 1 is the loneliest number that I've ever known, number 1. So the final answer to this problem is 1. When everything cancels, you're still left with 1. Dividing rational expressions is just like dividing any other fraction. You have to remember the rhyme. Dividing fractions is as easy as pie. Flip the second and multiply. Okay? We multiply by the reciprocal is the high-tech words to it all, if you prefer. And that simply means that we have to leave the first fraction as it is. So I have 4y minus 8 over y plus 2. I change my division into multiplication, and then I flip the second fraction, which means the bottom becomes the top and the top becomes the bottom. Now it's a multiplication problem just like the previous one. We factor each of the numerators and each of the denominators and see if we have factors that cancel, and then we simplify. So in my 4y minus 8, I notice that there's a greatest common factor. 4 goes into both of those terms. So I'm going to pull out the 4, which would leave me with a y minus 2. Make sure you divide and not subtract. Remember, you can always check by distributing back in. 4 times y is 4y. 4 times 2 is your 8. On the bottom I have y plus 2. There's no greatest common factor there, and y is to the first power. When there's no power up there, remember that's God on your shoulder. He, she, it is always with us. The God of Mathland is a 1. Since it's y to the first, I cannot break that down any further. Like I did on the earlier problem though, I want to put the y plus 2 in parentheses to remind myself that it's that entire quantity. You need to think of it that you pulled out a 1 out of there, and it's out in front, so you have 1 times that quantity. You can think of it that way as well. And then we continue on. Y squared minus 4. No greatest common factor there. And we have 2 terms. When we have 2 terms, we should be looking to see, do we have the difference of 2 perfect squares? Y squared is a perfect square, 4 is a perfect square, and we are subtracting. That means we do have the difference of 2 perfect squares, which would factor to y minus 2 times y plus 2. Remember, those signs have to be opposite, so when you FOIL, the OI cancels out. On the bottom I have y minus 2. Once again, no greatest common factor, and y is to the first power, so I can't do anything else with that. But that entire entity is 1 factor, so I want to put parentheses around it to remind myself. I cancel all of it or none of it. And now we do have the fun canceling. Anything on top that matches with anything on the bottom gets canceled out. It doesn't matter if it's right on top of each other or diagonally, as long as one of the factors is in the numerator and one of them is in the denominator. So we get to cancel. Ooh, y minus 2 over y minus 2. Ooh, y plus 2 and a y plus 2. Oh, there's another y minus 2. Can't I cancel that? No, this one's already canceled. It's gone. You can't cancel it twice. So what am I left with? Well, we're left with just that quantity, 4 times the quantity of y minus 2. Leave it in factored form, because if we want to do something with that, we like factored form an awful lot. Don't feel like you have to multiply anything. So to simplify, we factor and cancel. To multiply, you factor and cancel. To divide, you flip the second fraction and then multiply by factoring and canceling. And that's how to simplify, multiply, and divide rational expressions.